know. That's a pretty standard equation that we're going to continue to use this year and in AP Calculus quite a bit. That just got to know it. So, all right, so let's see if we can use this guy to help us. Okay, so remember, first we're going to check for factoring, then see if it doesn't work, use the formula. So let's find the zeros of f of x equals x squared minus 19x plus 90. We'll start with that one. Okay, so our factoring, the way that we approach that depends on the equation. If it's one like this, where there's just a 1 for a, those are the ones we want, because then the process becomes pretty simple. You're just looking at these back two numbers then. And what do we want to know about these back two numbers? How do we use them to help factor it? Plug in those two numbers? Well, we're not using the quadratic formula yet. So how do we use it to factor, though? Yeah.
What adds into negative 19 multiplies to 90?
Right. We're looking for two numbers to help us factor. And those two numbers have to add to negative 19 and multiply to 90. Okay? So, we know what those are? Negative 9 and negative 10. Mm-hmm. So this is going to be f of x equals x minus 9 times x minus 10. Okay, so that's the factored form of this quadratic. So then what are the zeros? What numbers, when I plug them into that, make the equation come out to 0? 9 and 10. Positive 9 and positive 10. Okay? So it's always the opposite of whatever the sign is on these guys. Positive 9, positive 10. Okay. Alrighty, let's try another one. So let's do f of x equals 3x squared. Let's see. Minus x minus 4. So again, first thing we're going to check to see is, can we actually factor this thing? Oh, whoops, hold on a second. I think I did that backwards. This should be plus 11 in the middle, sorry. I was quickly multiplying it in my head and it didn't work. It would have worked too? Oh. Yeah, okay, well, anyway. We're going to do this one instead. So, now if I have a coefficient on x squared, okay, I can't go back to the well like I did here and just look at these back two numbers to try and factor it, okay? Because I'm not accounting for the fact that this is now a 3 in the front instead of just a 1, okay? So we had a process for these guys, too, to factor them. Anybody remember what we do to get started on these? Yeah. Okay, so the a and the c get multiplied together. In this case is negative 12. And so now we look for two numbers that multiply to this, negative 12, and add to 11. Okay, so can we come up with two numbers that make that happen? Can we multiply two numbers and get negative 12, but add two numbers and get 11? 12 and negative 1. Right. Now, that doesn't mean that that's the way I factor it, though. It's not just x minus 12 and x plus 1. or what do we say? X plus 12 and X minus 1. That's not the easy trap to fall into, okay? A lot of people would be like, oh, okay, so 12 and negative 1, so there, factored it. What's wrong with that? Yeah, try multiplying this back together. Do I end up with this? No, right? I don't have that 3 in the front anymore, exactly. And in fact, I'd have a minus 12 in the back, and there should be a minus 4. It just doesn't work, okay? So with those two numbers. What we're doing with those two numbers is we're using them to help break up the polynomial into 4 terms instead of just 3. So that we now get 3x squared plus 12x minus 1x minus 4, like that. And from here, we use the technique of grouping to factor it the rest of the way. We group the first 2 terms together, we group the last 2 terms together, factor out a GCF, factor out a GCF, and go from there. So just the first 2 terms, what's the greatest common factor? 3x. So if we take out 3x, we have x plus 4. What's the GCF of the back 2? Negative 1, x plus 4. Okay, so then we're going to end up with our 2 factors are actually 3x minus 1 and x plus 4. So now I can look at my 2 factors and come up with my zeros again. Oops. One of them's probably pretty easy. The other one you might have a little trouble with. So give me the easy one. Negative 4. Okay. Again, as soon as we have a coefficient on these guys, people tend to struggle with it. 3x minus 1, what number, if I plug it into that, is going to make that 0? Yeah, 1/3. Okay. Kind of the trick to remember what that is. Yeah, it's this number, change the sign, positive 1, but then divide by this. 1/3, 1/3. Okay, and think about it. If you plug in a 1/3, 3 times a third is 1. 1 minus 1, 0. That's what we want. We want it to come out to 0. So 1/3 would be the other 0. Okay. So both of those we were able to factor. Just one was easy, one was a little more difficult. So if let's say this second one, I wanted to just go and use the quadratic formula instead. So, okay, so I'll just show you that process. So this is doing the factoring route. Over here we'll quadratic formula the thing. So A equals 3, B equals 11, C equals negative 4. So then we've got x equals negative 11 plus or minus the square root of b squared, 11 squared, minus 4ac, all divided by 2a. So when working with the quadratic formula, to be safe, just under the square root first, get that down to one number, and then from there it's usually not too bad. So negative 11 plus or minus the square root of, looks like 121, 4 times 3 times 4 is, it'd be 12 times 4, so 48. So plus 48. And all of that divided by 6. So that's going to be plus or minus the square root of 121 plus 48 is 169. What's the square root of 169? 13. So negative 11 plus or minus 13 over 6. So if I do negative 11 plus 13, that gives me 2. 2 over 6, 1/3. And then if I do the subtraction, negative 11 minus 13 is negative 24 divided by 6, negative 4. So same 2 answers. Okay, so yeah, like I said, quadratic formula, it always works. So if you don't like to do the factoring, you can just jump right in and do that instead. Very last thing, and then I am done, I swear, is I forgot to do this. I should have done this when we were talking about vertex form. But there are going to be some questions in your homework, and I inevitably get people confused by them every year, so I just wanted to do one with you. We're going to find the equation of a parabola with a vertex given. So let's say equation of a parabola with a vertex at 1, 3, and it's also going to go through the point, bless you, let's say 4, 12. Okay, so if we were to look at just a quick sketch of this thing, so at 1, 3, there's the vertex, and then it's going to go through 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So then 12 is like up here somewhere. Here's 4. So we've got a parabola that looks kind of like this. Okay, yeah, I know. It's not to scale, but you get the idea. So it has that vertex though at 1, 3, and then it has to go through the point 4, 12 as well. Okay, so what we can do is, since we know the vertex, what form of a parabola do you think is going to be good to start with here then? Yeah, if we start in vertex form, and just plug in our h and our k, we're already most of the way there then. So we have a times x minus 1 squared plus 3. Okay? Now, we have this other point, 412, that we can still use. And what's the only other thing we need to know about this equation to write it out completely? A. So what do you suppose I can do? Yeah, if I use this point, right? This point is another x and y that is on that curve, right? So if I plug in that x and that y, I can then solve for a, and I got it. So that's what I'm going to do, because this is actually just y, right? F of x and y are the same thing. So I've got 12 equals a times 4 minus 1 squared plus 3. So 12 equals 4 minus 1 is 3. 3 squared is 9, so I got 9a plus 3. 12 minus 3 is 9, so 9 equals 9a, so a is just 1. Okay, did some quick algebra there. And so then my equation, then, I can leave it in vertex form because it didn't tell me which form it wanted it in. A is just 1, so it's just going to be x minus 1 squared plus 3. Like that. Okay? So you can do problems like that too, using vertex form. Okay? It's just a little bit of different information they're giving you to start. Okay, I'm done, I swear.